something here. Okay, today I'm going to use screen lah, yeah, for easier to share the thing that I'm going to have today. Okay, another. Okay, before we go to the WECA, just want to brief you again, yeah. I takkan buat slideshow tapi I go through directly, yeah. Hopefully you can see, yeah. Moreover, I do not open my webcam due very low bandwidth, ya. Normally afternoon, so saya takkan buka saya punya webcam. Hope it's okay for you, eh?
Okay, Doctor.
Right, thank you. Okay, so what we have done last week, yeah. Firstly, before that, going to there are two targets for this today evening. We have to focus on using WECA, and then I will go through the association a little bit, go through the clustering. Okay, the clustering part is actually have been given the apa nama reference, yeah. And yes, okay, for the association part, what we have done
Doctor?
is, yeah.
Do you mind if I start the recording?
Oh yeah, nanti saya startkan, ya.
Okay, thank you.
Let me. Okay. So what we are going to look will be on the FIM, this concept algorithms. Okay, if you remember under association, there are two main tasks, yeah, that we are going to see the how WECA shows the results, and also how you understand the results in the WECA. Okay, there are two steps here, yeah, when applying the association, which are the frequent patterns, and also generate the association rules. If you look at the frequent patterns here, yeah, we are using support as the measure to determine these combinations or these item sets are frequent. And secondly, we use measures, yeah, which is confidence, to determine that these rules are significant or accurate, reflecting to the context of transaction database given to you. Okay, so let us try to have a look at the effect of applying a priori, yeah. So first of all, kejap ya. Bila screen dia lari macam ni, saya kena close dulu. Okay. Okay, let me open it back. Okay, so open a file from your WECA directory, supermarket. Yeah. I hope you also have gone through the word file yang saya share for these exercises. Dah rujuk ke?
Yes.
Ada yang dah, ada yang belum? Ada yang belum? Yeah. So you can go to the MS Team and then go to the general post. There is an exercise for association week 11. Okay, we are going to use supermarket dataset here, ARFF. Okay, if you look at this description of data, it has 4,000 instances and then it has 2,000 attributes here. Yeah. And if you look at the instances, yeah, so supermarket is actually about product can be found in different and also products itself. Yeah, the name of the attributes will be the name of the product, or it just department 176 or so forth. Yeah, any products that can be found in that departments. Okay. And if you see there is another attribute here, a class label. But firstly, I want to demo doing extracting item sets and also association without the class label. Okay, so what we are going to do is that to remove total here. Okay, click remove. Okay, so now there will be your data. Okay, you can have a view on the data set here. Okay, if you look at this, yeah, department 1, department 2, and so forth, what will be here in the data set will be a lots of missing value. What does it mean by this area? Any idea? What does it mean by this area?
Null or missing?
Null or missing? Any specific other apa nama description that you can give here?
Non-existent.
Non-existent. Okay, let's have a look at here. So this is transaction 10 says that the apa nama item bought by the customer is product A, product B, product C, and then 20 product A and product C. So can you relate to this? Boleh relate tak? Maksudnya, ya, customer 1 bought apa dia? Beli apa?
There's a few items from all of the items available.
Yes. So you can see here, the customer 1 bought product from baby needs and then bread and cake, baking needs. Yeah. No coupons bought. Yeah. I'm not sure why coupon is something items to be bought. Okay. And then juice and so forth. Okay. So these are actually products by first customer or first transaction. Okay. The one without any information is actually product is not being bought by the customer. Okay. So this is very important. Missing value doesn't mean the data is not there, but in this context, it means that the customer do not buy this product. Okay, so if you look at the detail of the data, you could see we have 4496. Okay, yeah, you can browse through here. Yeah, browse through and then you can see product bread and cake is normally among the among the frequent items or frequent products bought by the customers. Yeah, if it's occur in all instances, definitely 100% customer had bought it. Yeah, becoming not significant pula, ya. Kalau semua membeli, dia tak jadi significant lah pula kan. Okay, right. So you can go through and then have a look at this item. Yeah, we can find here insecticides also another product 90%. Okay, and so forth lah. Yeah. Okay, now if you realize also your data is T is actually presenting as true lah, yeah, and your apa nama the description here is all attributes are nominal. Okay, right. Okay, now let's have a look at associate. Okay, go to the tab as associate. Okay, and then go to the choose here. Okay, click a query. Yeah, we are going to apply a query. Okay, now let's have a look at the setting here. Okay. As I mentioned, this experiment is for car equal to false. Okay. So we omit to describe that one first. Okay. We go to this, yeah, lower bound, and also another important point, important apa nama parameter is here, yeah, the confidence, yeah. So actually we can use other metrics, but now we are going to use confidence. Okay, remember? Okay, remember support is for the item sets, right? And then we have confidence. Confidence is for the association. Okay, by default ditunjukkan berapa di sini? Lower minimum bound. Berapa?
0.1.
0.1 kan, and then confidence also 0. Meanwhile confidence 0.9. So we want to have here, for example, we are looking for products being bought frequently with a high threshold, yeah. So put it as a 0.9 for the lower bound, yeah, and then confidence equal to 0.9. Okay, number of rules biarkan 10. Okay, and then the rest should be let it as a apa nama default. Okay, and delta means that the changes of 0. From apa nama from the highest one till the lower bound, which is 0.1, yeah. So it will be changes at the 0.05, yeah, factor. Okay, click OK. Okay, and then click start. Okay, so now you see here my result shows that it's been run and then no large items and rules found. Okay, so it shows that the apparel does not able to get any combinations and also rules. Okay, so like I mentioned just now, it's always depending on the setting, the value that we have set just now. Okay, so the threshold of support value could be high, yeah. So what we can do is try to reduce it, yeah, try to reduce it to 0.7, for example. Okay, and then or you wanted to maintain the 0.9, but you want to change the confidence of the what we call rules, yeah, to the slightly lower. So click OK and then click start. Okay, still there is no, yeah, shows that 0.1. Yeah, we normally do not practice to reduce the confidence to apa nama very low value lah, because this will imply, I mean, this is the knowledge base that we want to gain. So let the confidence at least 0.5. Okay, that will be the best practices lah. Okay, so what we want to reduce will be the support value, I mean the threshold of the combination. Okay, let us try to go for 0.7. Okay, and then you can click OK. Right, and then click start. You get any rules ataupun combination? No large, yeah, no large items found, and then rules also found. Okay, so what we can do is that, okay, since there is no large items, definitely it shows that the combination is quite high. So go to the 0.5, okay, and let the confidence 0.9, and then click OK, and then click start. Okay, so this now you at least have the result for the item sets. Okay, so look back here, the description of item set is about finding the patterns. Okay, so it's it will start with k equal to 1. Yeah, I mean it's referring to the product, yeah, single product. Okay, and then it goes to the combination of 2 items, and then it will iterate to the 3 item if there is apa nama the golden rules is applied, yeah, under a priori lah, I mean under a priori. Okay, so look back here, right? So yeah, here we can see that there are 9 items, yeah, a single item can be found with minimum support of 0.5, and then if you look at two combination also can be found too, but there is no best rules. Let us have a look at the item set. Actually, we can have a detail, we can have a look at the what is the item set here. So you can go to the output item set, yeah, and click or choose true. Okay, and then click OK, and then click start. Okay, so this is what are the frequent items for iteration 1. Yeah, so we can see that bread and cake occurs 330, and then the rest also here showing the count of each, yeah, count of item, each of item. Okay, so let's have a look at bread and cake 330. Yeah, 3330. Yeah, 3330. Okay, let me have a check here. Okay, ada calculator saya. Okay, yeah, 3330. Okay, and then we have, okay, we have bread and cake, which is 2795 over 4627. Okay, 60%. Okay, so items that will be at least 0.5, yeah, at least occur 0.5 will be shown here. Okay, and then this will be the combination of two. Okay, combination of two items. What are the items? Okay, this one is considered as one item, walaupun you kata nampak N ni di sini, tapi dia consider one item in the data set. Okay, and then we have milk cream, yeah, milk cream. Yeah, so these items together occur together, yeah, at the count of 2337. Okay, so 2337 divide by berapa tadi? Yeah, so more than 2314 definitely. Okay, means that is more than 50%. Okay, okay, this part is clear, right? This part.
Clear.
Okay, clear. So you can reflect to this outcome. Yeah, this outcome for the step 1. Okay, now we are going to have a rules. Okay, so what are the candidates of rules? So L, okay, let me show you the other part which will be important here. Okay, so if you look at the description of a priori, we have C and also we have L. L will be the frequent, which is C is referring to the candidate. So we already have the frequent items of two combination here, bread and milk cream. Okay, so what are candidate of rules that can be generated from this one? Any idea? What are rules that can be generated from this combination? Apa dia? Any idea?
If someone buys bread and cake, they might buy milk or cream.
Okay, right.
But
so
I
it
think
was,
milk and cream should be combined, isn't it?
okay, it will be look like this lah. Okay, you could have combination of A and C. So what are the candidates of rules? A implies to C or C implies to A. So we have two possibility here from bread and cake and also milk cream. So we could have bread cake implies to milk cream or milk cream implies to bread cake. Same goes to the second, yeah, the second combination here. Yeah, so we are talking about these two item sets that can produce rules. This one, for this part, definitely there are no rules. Okay, but again here we could say that when we put it as 0.9, the confidence factor of 0.9 is too high, yeah. April search it from the database, cannot find these association rules. So what we can do is that to reduce the minimum, yeah, minimum value for the confidence, right? Okay, start. Okay, let's see here, yeah. So at least you could see there are 3 rows being generated, yeah, which milk cream implies to bread and cake, and also bread and cake implies to milk and cream, and both it shows the confidence. One showing confidence 0.8, okay, 0.7. Okay, based on the theory that you have learned during knowledge base. Okay, when this is considered as complete, means that the combination is same, but the direction is different. Means that milk cream implies to bread cake, or bread cake that implies to milk cream. So back again, can you remember the one that you have learned during knowledge base? So how you going to determine this would be the best rules? Mm-mm.
Is this related to conflict resolution?
Yeah, okay.
Okay, so the first row
Uh-huh.
that is being fired should be
Okay,
prioritized.
right, good. So means that we can reflect to the confidence value. So we should choose the milk cream implies to bread cake. Means that we confidently say the customer who bought milk cream will also buy the bread and cake. Okay, so how much confidence that you can give here? The confidence is 0.8. Okay, clear? Boleh faham?
I think so.
Boleh.
Okay, the rest? How about the rest? Yang lain senyap?
Boleh doktor.
Boleh eh? Okay, so next we could see here we have another rules generated here. Fruit, yeah, fruit implies to the bread and cake. As we have gone through just now, bread and cake ni actually considered as very high mana tadi, bread and cake, yes. We can see that the count is quite high here, yeah, for the bread and cake. Means that most of the customer buying this product, yeah. Right, so in order to determine which kind of combination, uh, what we call combo, what will be the best combo that you can give discount, will definitely based on this association being found here. Probably you could give the apa nama, the discounts to those who are buying milk cream, yeah, compared to buying fruit, yeah. But though here confidence is very very low, probably you just want to say, okay, siapa-siapa yang beli bread cake have another discount with any other product as well. Okay, that can be done also, but the discount could be very very not to say too high, but it could be because it's common, so everybody can get discounts, and everybody happy with that. So you could give 10% discount, should be okay. Okay, but in order we have, when we have a look at certain product which hardly been bought, that one one would like to induce some power on the discount, so on the sales, so you give more discount on it. Okay, saya take a break kejap tengah azan. You can go through and change change the parameter lah, to have a look at different, orang kata different rules being generated. Yeah, you can change here.
Ibu, kakak tengok cerita tak elok.
Okay. Okay, as you see, I have tried to run several metrics here for the confidence. So this is the one that I have tested, which is confidence 0.5 with support vary 0.4. Okay, so I gain more combinations. Yeah, still the combination of 2 will be um the largest. Yeah, we cannot gain 3 combinations here. Okay, let's have a look at the rules. Yeah, so rules can be, I mean, the number of rules generated can be changed. Means you can, by default, it will be 10 rules, but you can change to have 20 rules, 50 rules, or more. Okay, so from here that I have been tested on the data set, we have biscuits, bread implies to bread cake. Yeah, as you see just now, bread cake would be commonly bought by the customer. Means there is showing some kind of the apa nama co-occurrence of the what we call items. Yeah, normally frequently bought with other product. Okay, do you have any discussion on these rules generated?
Nothing at the moment.
No.
Okay, let me point out, like what, let me point out, okay, this one probably not shown here, yeah. Tak ada dalam ni. Okay, okay, let me just okay, so there is no, okay, yeah, I remember this. Why do I do not get that one? But it's okay. Okay, let's have a look at 10 rules. Okay, so have a look at here. You go to the apiary and then, okay, saya nak kena buat lagi sekali. What I want to show to you is how we can have a visualization of the generated rows. So what we can do is that click to stop visualization. Okay, this one is ten. Okay, I just choose 10, 10 best rules. Okay, so now go to the apiary, right hand click. Okay, this will be taking a little bit of your RAM. Go to the plugins, and go to the AR rules viewer. Okay, as you seen here, this will be rules, and you can select all. Okay, and this one can be sorted. Yeah, choose the how the rules been viewed. Yeah, in the 3D representation. Like I want it to be shown as the confidence. Okay, and then the criteria also based on the supports is like, okay, and let's have a look at the outcome. Okay, So this will be the rules generated. Okay. Oh, besar sangat. Nampak Ataupun you boleh buat juga if you have enough memory. Okay. So this is the rules that you can view here. There are rule 1, rule 2, rule 3, rule 4, and so forth. Yeah. And then as you see at the y-axis is showing the confidence and also the support value. Yeah. Okay. And this part will be in 2 colors. Yeah. So like what you see for the first rule is the milk cream implies to the bread and cake. Yeah, bread and cake in the red color. Okay, and then we have, oh sorry, the first rule is the biscuits. Yeah. Okay, biscuits. Okay, and then the second rules will be the milk and cream. Okay, and then yeah, and then we have this is based on support. Okay, since we are talking about rules, we want to sort it by confidence. Okay, let's see. Oops. Okay, so I can see that this rule number 1 is the highest confidence. Okay, and then which is discussed just now. Okay, and then the lowest confidence will be the rule number 10, which is bread and cake implies to the baking needs. Okay. I think, yeah, let me try if it can produce. Yes, I think it can, it has no problem if you want to try to produce or to visualize. Yeah. Okay, so I mean, it also can show all 20, yeah, 20 up to 20 attributes. Okay. 20 attributes here, and then this will be the antecedents and also the consequence. Okay, let us try to sort it by this conclusion. Does give any effect? Oh, okay, so much. Okay, confidence, sort by conclusions. And sort by Stevenson. Okay. So this is how you can use the visualizer for the rules. Okay. So this part okay, clear? Boleh?
Clear.
Okay, now what we want to do is that to apply car ataupun classification association rules. So please reload the data set, because we need the class label. So here we go to the supermarket. Okay, open, right, and then go back to the associate. Okay, and then we go to the apriori, and then here under apriori, let's set the true car equal to true. Okay, and it will select the most the left, yeah, the left, the right, yeah, the right column as the class index. Okay. And then we have tried just now, so let us try to have a very low minimum support value 0.3, and then with the confidence 0.5. Okay, and then click OK. Okay, and then click start. Oh, masih tak ada. Okay, so mungkin kita kena reduce the minimum, and then click OK. Okay, click start. Okay, so this part, if you look at your generated rules, yeah, yeah, so there are these are the list, and also there are 3 item sets, yeah, 3 item set: bread, cake, fruit, and also vegetable, with a count of 1791, yeah. Apa ada L? Okay. And then this one will be the rules generated. As we see here, the transaction can be classified as high and also as low. Okay, so this would be the one that have been generated. Okay, saya mencari satu rules yang saya jumpa ni kejap. Is there any the rules? Okay, mungkin rules tu kena generate dengan lebih banyak. Okay. Study tu Okay, another thing that I want to highlight is that there would be certain rules could be implies the same. The antecedent part and also the consequent part will be conflict. Okay, that one also probably will be discovered among the rules that generated. However, I'm able to see just now, tadi saya jumpa rules tersebut, tapi yang ini saya tak nampak mana rules tu baking height and width. So that I can show you baking biscuits. No, this is not the same. Tak sama. This one tak sama. Okay. Okay, never mind. So in case that you found a rule, 2 rules of 4 rules, for example, yeah, that has the antecedents same, but the consequent different. Boleh faham tak maksud saya? You understand? Say that pick up, yeah, let us pick up this one. Okay, for example, this rules the rule is frozen foods, party pack fruits implies to total height, and then you see there is another rules. Okay, frozen fruit. Okay, frozen fruits, party pack, party snack foods, and fruits is implies to total equal to low. Okay, the confidence would be mungkin sama ataupun mungkin tak sama. So how are you going to deal with these rules? Any idea? Any idea? Tak ada jawapan. Hello?
Saya tak pasti.
Kalau kita ada dua rows, dia punya left hand side sama, and then right hand side dia berbeza. So rows mana yang you nak ambil?
Take the highest confidence.
Take the highest confidence. Okay. Ada lagi? Siapa-siapa nak jawab? Kenapa you take the highest confidence? Because why? Kenapa you nak ambil yang highest confidence? Yang itu lebih accurate.
Dia lebih accurate.
Okay, ada lagi perspektif? Ada lagi idea yang lain? Okay. Ada lagi? Nak bagi idea? Ni machine learning juga masalah lah. Kalau you masukkan rules yang salah dalam machine you, macam mana? Dia akan decide macam mana? Dia mungkin akan buat decision yang salah kan? So how do you deal? What if I say that, okay, because it's so different consequence. Again, regardless of the confidence itself. And I want to play safe. So what I do is that to remove both rules. Is it okay?
Ikut.
Kan? Ya, ataupun you nak buat yes. Ataupun macam Iqbal suggest, kata buat or ataupun and. Itu boleh lah. Okay. But that is the thing that we probably facing in terms of getting the rules, generating the rules. When we have conflict, then you have to think about how to deal with the conflict. If possible, we can. If possible, we need to reduce the conflict that might occur. Yeah. Okay, I leave the questions ataupun the discussion to you later on if you want to discuss with your friends or so forth. Okay, so that will be part of the association. In case you have any questions, you might want to ask now.
Doktor, worker saya ni tak dapat nak buat 3D punya visualization tu. Dia tak ada
Guna
yang
apa sekarang?
apa dia?
You guna yang mana sekarang?
Version
So sekarang ni, kalau you gunakan car equal to true, you can see there is no option kat sini. Hasil kita tak boleh nak gunakan 3D.
Tak, yang tadi pun tak boleh kak.
Yang tadi pun tak
car
boleh
false.
ya. Mungkin saya pun tak boleh nak jawab yang tu, kata dia punya whether is sebab ni yang ini you klik tak?
Yang tick box tu pun tak ada.
Tick box pun tak ada. Okay, mungkin you punya version lah tu.
Itulah,
Version
saya
tu
update.
version dia tu mungkin lain sikit. Okay, mungkin tak ada yang ni.
Okay, baik.
Sometimes it could be limited by the the Java itself lah kan. Yang lain ada soalan? Kalau tak ada kita continue. Okay, so that one will be the the discussion on the association. Okay, let me bring back to the exercises that we have here. Okay. Okay. I have posted this one, Okay, I posted this one in your in the general post, though we can have a look at the task is that to do on the iris data set, and then the iris data set to perform, yeah, in this is what you need to understand in terms of purely to do unsupervised method. We assume that your data do not have any class level, so that's why in this particular exercise we remove the class attributes. Okay, and then if you want to retain pun tak ada masalah sebenarnya. It can help you to understand. Okay, it can help you to understand the the description of the data. What we can do is that here we can apply simple k-means. Okay, and here if we apply simple k-means, yeah, is actually a try and error. We could have a different set of centroid or clusters starting from 2, 3, 4, 5, and so forth. Okay, for that purpose, we could also define doing it using different distance value. Like here you can apply Euclidean distance, or you can apply Manhattan distance. Okay, so when you apply this one, these are among result that you can see for the what we call clustering. And the result of clustering here showing something, yeah. Okay, let me ask you. Okay, let me ask you, when you do clustering, okay, wait, okay, when you do clustering, yeah, this will be initial points being generated, yeah, in your Weka results. Okay, what do you understand, or do you know what is 6.1 and then what is 2.9 here, and what is 4.7? Apakah itu, ya? Apa dia? Ada jawapan?
Is it starting point for we calculating?
Okay, so ini adalah starting points di cluster kosong. This is starting point in cluster 1. This is starting point on cluster 2. Tetapi yang saya tanya ni adalah ni lah. Apa dia ni? 6.1 ni apa? 2.9 ni apa? Any idea? Ada? Sesiapa boleh beri jawapan? Ke nak kena buat juga baru faham? Okay, I believe most of you have done this part, yeah. So you try with 2 cluster and then 3 clusters. Okay, and finally you might try to have 4 clusters. Okay, mungkin ada yang dah tukar kepada 5 clusters. Yeah, 5 clusters. But my question here, yeah, so here you have the 6.1, and then kat sini pun you nampak ada 3 points dan dia 6.1, So ni apa ni 6.1 ni? Tu value apa?
Value sample length.
Yeah, okay, thank you very much. So ini adalah reflect kepada sample length and this one is 2.9 reflect kepada sample width. And then we have 4.7 for petal length, kan? And then 1.4 is for the petal width. And lastly will be the class. Okay, so these are the centroids. Means that for centroid, because our data now we have 5 attributes. Okay, in case that we have 10 attributes and so forth, so you can see a long list of attributes here, yeah, for each the centroid. So centroid ni dia akan ambil secara random, and then secara random to represent cluster, each cluster lah. So if you look at here you have 2 centroids, initial centroid, this one is 3 centroids, and this one is 4 initial centroid and so forth. Okay, now if you look at the results here, ini adalah menunjukkan apa pula? This part. This one. What that it shows here? This one is referred to what? Tunjukkan apa? Anybody? Ada siapa boleh faham? Okay. If this is the initial centroid and this one is the
Plotted ke doktor?
Huh?
Plotted.
Plotted. Tak nampak graf kat sini. Okay. So kalau ini adalah initial centroid, yeah, and this is the final cluster, and this one menunjukkan
Final centroid.
apa dia?
Final centroid.
Final.
Okay, thank you. This is the final centroid. Final centroid of cluster 0, and then final centroid for cluster 1, cluster 2, and cluster 3, and cluster 4. Yeah. And ini pula adalah the total of objects or instances in cluster 0. Okay, this one is the total of instances in cluster 1. Okay, cluster 2 ada 50, cluster 3 ada 50, then cluster 4 there are 12 instances. Okay, boleh faham? Okay, and then all you can see in the percent here, shown here. Okay, and other information that will be important here would be the number of iteration and also the within cluster, in between, the sum of squared errors within cluster. Okay, so this actually the distance between object in the cluster. Yeah, remember that we have learned in the introduction of cluster, we would the algorithm will check the intra and inter cluster. Okay, so what you can generate here in the Weka would be the intra ke inter within cluster. Does this reflect to intra or does it reflect to inter cluster? Intra, yeah, very good. So yeah, objects in the same, in the same cluster. So the distance must be smaller lah, definitely. But there is an issue, okay? definitely if we reduce the number of cluster, okay, the inter-cluster would, I mean, the distance would be smaller and smaller. Okay, have a look at the results here. So the result can be visualized using the scatter plot. Yeah. So if you put it into the scatter plot, okay, and then map into x equal to the number of the instances, and this is the cluster. This would be the view of the the view of the clusters. Okay. So again here, I believe some of you or most of you have gone through how we are going to evaluate the clustering. Okay, so it is referring to the what we call elbow effect. Yeah, this is the apa nama the what we call the value of sum squared error. Okay, so what is elbow effect? So elbow effect will be showing the effect of the errors that been captured, and first we could see the elbow effect when what we call apa nama when the data shows more stability like this. Yeah, so first is dropping. Yeah, it will be dropping into some value clearly, and then it's becoming like a very small difference. So the best number of cluster would be the first when it dropped. Okay, so as you see here, we are using iris dataset. Yeah, so iris dataset actually have 3 clusters, so that's why here we could say that the 3 clusters will be the best number of cluster. Okay, but the real or the actual class level can be the guidance of determining the elbow effect, but this is the case where the actual class level is known. But when we do not know any class levels, you probably can opt for that one also lah. Yeah, so you can see there would be the first dropping will be, and then when it becomes more stable, so that will be the best, the elbow effect. Okay, you can also make reference here, yeah, in the YouTube. Yeah. Meanwhile, there will be another clustering algorithms that can be used, which is hierarchical. So the difference between k-means and hierarchical is that hierarchical would be showing the nested cluster. Okay, and consider you would produce some kind of dendrogram or overlap, yeah, overlap cluster. Okay, in doing this will be based on the original iris dataset. We hardly see the objects that belongs to the cluster. So what I tried to apa nama kejap sorry sekejap. Okay, sorry. Okay, now I try to put it clearer. Yeah. So how what I did is that I have reduced the data into 10%. Okay. So I rerun on the Euclidean distance using the singling. Yeah. For the hierarchical, and this will be the view of uh, the cluster, nested cluster. Yeah. Okay, as you see that this is the first clusters, and then this is second cluster, this is third cluster, fourth cluster, okay, and then this is fifth cluster, and this is six clusters, and then this is 7, 8, and then 9, and finally the 10th cluster. Yeah. Let us try, or you can try later on to have a look at a single versus complete link. Apa beza antara single dengan complete link? Apa beza dia? Single gunakan apa? Okay, you can check nanti what is single, what is complete link. Okay, and this is through Manhattan. And you can see that will be giving a different different nested dendrogram when we use Manhattan and when we use Euclidean and when we use single and also complete link. Okay, other tasks that can be done is that on the clustering, but for the purpose of classification. I hope you can also test this one, to see to see in the context of classification what or how you can use clustering algorithm for the purpose of classification. So this will be what we have in clustering algorithms using Weka. Okay, you can do it later on, or I think most of you have done it. You just can have a check with what I have done, ataupun samples of results that I have done. Okay, any questions? Tak ada soalan?
Tak ada kot madam.
Okay, kalau tak ada, I think that's all for today. Okay, I still be around in case you have any questions you want to put it in the chat. Okay, you can always tanya sekarang, tanya. Okay. If there is no question, so I think that's all. You may leave now, or you want to you want to stay in the class ataupun in the chat. In the chat also boleh. Okay, and then don't forget to fill the your future, your attendance in the your future. So I think that's all. Thank you very much.
Okay, thank you, Doctor.
Thank you, Doktor.
Okay, welcome.
Doktor.
Assalamualaikum, Doktor.
Ya, salam.
Saya nak consult dengan doktor tentang dataset.
Aha, okay.
Sekejap, saya share skrin. Nampak ke, Doktor?
Aha.
Jadi dataset, kita orang tukar dataset tapi masih berkaitan dengan video game.
Okay.
Total attribute adalah 34, 32 numeric attribute, 2 nominal attribute. Kelas dia adalah ESRB rating. Kita orang fikir nak guna classifying method untuk this dataset.
Okay. Ada numeric tak? Tak ada ya?
Ada numeric tapi cuma 32 numeric attribute. Dia yes no 1010.
So actually dia adalah nominal lah. Kan?
Betul.
Okay, and then how you going to explain about ESRB ni? Macam mana you nak explain pasal ESRB tu?
ESRB rating ni adalah rating yang diberikan selepas take into account some of the criteria. For example, is there any alcohol reference, blood and gore in the animated video game? Is there any vulgar language? So nanti kalau contoh kalau semua tak ada alkohol, tak ada sexual content, tak ada violence, the rating of the game will be E, everyone.
Mana earphone Duha?
Oh, kejap. Atas meja tu, atas meja.
Earphone.
Atas meja.
So kalau game tu ada violence or use of drugs and alcohol or use of alcohol, then the game will be rated as teen, 18 and above. Maksudnya
Maksudnya dia boleh view by teenagers lah masa awak.
maksudnya teenagers 18 and above only yang boleh main game tu. Kalau certain game tu only have mungkin mild blood ataupun mild cartoon violence, maybe the rating would be everyone above 10 years old. And so on. Ini everyone 10 years and above. This one is mature 16 and above. This one is teen 18 and above.
Okay, faham? Alright. Saya rasa bolehlah cuba ni untuk guna dataset ni. Okay. Semua ada kelas name. Atas sikit dia punya attribute ni boleh tak? Title and then we have console. Yang mana numeric?
Numeric sepatutnya semua ni selain title dengan ISP rating. Tapi dia punya numeric tu just 1 and 0.
Okay, faham? Alright. Saya rasa tak ada masalah. Boleh continue nanti. Boleh buat untuk classification. Ya? Yeah?
Okay. Thank you for the comment, Doctor.
Okay.
Thank you, Doctor.
Right, welcome. Amirul, Amir Hafiz, are you there? Tak ada dah kot.